Alright guys, we're back at it again. Today we're looking at graphing f of x equals parentheses x minus h close parentheses squared. Our central question is how can you describe the graph of f of x equals a quantity x minus h squared plus c. So far we've been looking at a, x, and c. We are now putting in the minus h. So recall a will either make it a stretch or a shrink, and c moves the graph up or down. A will also make a reflection if it's negative. Let's look and see what happens with H. My computer's having fun today. So notice that H is negative in our equation. So when we get f of x equals something like x plus 4 squared, it's really f of x equals x minus negative 4 squared. And so our h is negative 4 in this situation. So you really got to understand this is x minus h. And so it's the opposite sign of what's taking place in the equation. So it's minus negative 4 because two negatives gives a positive. The easy way to remember it is it's always going to be the opposite of whatever our operation is going on in here. But h is negative in this case. So let's do a little work. So we want to look at when h is bigger than 0 or positive. When h is positive, the graph is a horizontal translation, h units to the right. H is positive. I don't know why there's an extra t in there, but oh well. So let's look at an example. F of x equals x minus 4 squared. Remember in this case, h is a positive 4. It's the opposite of what's going on in here. This is minus 4, so h is a positive 4. The negative from the equation makes it a positive because two negatives, a negative times a negative gives us a positive. Our red graph is x squared. I'm sorry, f of x equals x squared. This is our parent graph. When we do the minus 4, it shifts our parent graph 4 units to the right, or h units to the right. Let's now look at when h is less than 0 or h is negative. The graph is going to be a horizontal translation, h units to the left. H is negative. Remember the equation is x minus h, so x minus a negative becomes a positive in the function. So when we do an example, we get f of x equals x plus 6 squared. In this case, h is negative 6, which is the opposite of what's going on here. And when we have this case going on, our parent graph is here in the red, starting at 0, 0. But we move 6 units to the left. You have to be careful. That's one thing you have to remember. We have one more idea we want to look at. Vertex form is when we have f of x equals a x minus h squared plus k. For some reason, we've been using c, and now our equation wants to change to a k. They're interchangeable. It's just how it is. So we get comfortable with it and we move on. If I ask you, what is the vertex? The vertex is always going to be h as our x and k as our y. What does that look like? Let's do an example. So given the equation g of x equals x plus 2 squared plus 3, remember h is the opposite of what's going on in positive 2, so it's negative 2. Our k is positive 3, so we just put that in for our vertex. Our vertex is negative 2, positive 3. Let's do one more, maybe two more. Let's look at h of x equals x minus 4 squared minus 7. Again, h is the opposite in here, so we get positive 4. K stays as the same over here at the end where c is, so we get negative 7. So our vertex is 4, negative 7. One thing I want you to be careful of is when we don't have a k. So we get f of x equals x plus 3 squared. H is negative 3, but since there's nothing here for k, we put in 0, and our vertex is negative 3, 0. So we've been practicing this a little bit on decimals. Now we know or have this in our notes. We've added how to find the vertex in our notes. Our assignment is going to be without graphing. I want you to compare the functions to f of x equals x squared, which is our parent graph. I want you to tell me, is it a stretch or a shrink? Is it a reflection? Is it a translation up or down or left or right? And how many units? What is h? What is k? And give me the vertex. Through all this in our notes previously, we can figure all that out without having to graph the equation. We can simply look at the function and we will know. Please use your notes from previous classes. We have 6 practice problems. Please give me all this information. Thank you.